Exploring one variable. You've watched the video introducing concepts, and you know that we have different variable types. And you've gotten a hint that we're going to be exploring, we're going to be studying variables, studying data, numerically and visually. In either case, we're trying to summarize data. Because data looks disorderly, we're trying to get some kind of summary statistics, numerical or visual, that will help us get a picture of what's going on. Data analysis is made up of these elements. And this is, I want to remind you that you need to memorize this. This picture, it's made up of exploration, which is what we're going to be focusing on today. And it's also practical significance, a written report, and inference. Today we're focusing on exploration only. Before continuing, I'll make sure you watch the first video and that you've completed exercise 2. So that gives you a little bit of experience with preliminary data analysis. You have to have a SPSS instructions book handy, and I'd like you to have SPSS program open on the computer you're using, or PSPP. And I've sent you information about how to download PSPP and SPSS separately. So today, in this video, we're going to be exploring one measurement variable, exploring one categorical variable, and introducing SPSS. Exploring, yes, going into the unknown, and being curious. Those are two important elements. I want to make sure you have those going on as you're watching the video. When a data set is ordered and studied, it's called a distribution. So that term, it's a term that is kind of hard to get a grasp of at first, but a distribution is really giving us a sense of capturing what is going on within a data set. And that's at the core of the models that statisticians love so much. So models are ways that we summarize data. So here's some visuals. Categorical, we have the bar chart. Remember, these are two separate bars. Here we have measurement variable, so it's got the more continuous kind of feel to the bars. And in categorical, we can also do a pie chart, which also gives us a sense of yes or no. In this case, obese or not obese, BMI, whatever the data that you're studying is. Categorical and measurement variables can be further subdivided as follows. Categorical as nominal or ordinal, and measurement as discrete or continuous. And in the previous video we talked a little bit about that. We can explore variables particularly or generally. And we're starting with, in this case, I'm just going to grab this here and change the color. Red. Okay, so we're exploring a measurement variable in this case. So that is something that is measured. It's not just classifications of yes, no, or hair color, or political party affiliation, or whatever it is. So we can do that particularly by looking at where does an individual score lie within the distribution. So within all the scores, where does your individual score lie? So where does your mark in comparison to others? So for example, a percentile is one way we do that. And so we can look at, if you want to compare yourself to other students, if you're in the 90th percentile, that means 90% of students have a weaker score than you. When we talk about generally, that's when we try to capture all of the data into some kind of one summative number or visual. So we look at center, spread, and shape. Those are things that exercise 2 we looked at trying to capture. And we use a histogram and boxplot to give us a sense of the spread and the shape and center, as well as numerical. So here we have a dot plot of individual raw scores when we have a distribution of ages of people at a Samuel Beckett play. So age of people at a Samuel Beckett play. So when we're going to look at age equals 20, what we see, there's nobody who's actually 20. But when we look at a probability of age 20, so probability of being of age 20, there's nobody, so 0%. Probability of age less than 20 is everybody who's here. And we count. 1 plus 4 equals 9. And so that's where that 9 comes from. And 9 out of 77 is 11.1169 or 11.69%. That from probabilities. Probability of age less than 20 of people at the Simon Beckett play. Now we could also look at it through a histogram. So that was a dot plot, that's one visual, which gives us each individual score. And the histogram gives us kind of a general view of the shape and where the center might be. And so we have each of these bars is a range of values. But we can still see that there's 2 people plus, that's roughly 3 people plus maybe 5 people. So we can still get around 9 out of 77 people are under 20 years of age. So you get the same information from a histogram. But we get other information, and this is produced by SPSS. We get 29.96 is the average, mean, standard deviation, and we get the number of individuals automatically produced. So what I'd like you to do is to find the probability that the age of a patron is greater than or equal to 40. So in this case, this is our dividing line here. So pause this video and take a minute to calculate that. Okay, and so we just calculate there's roughly 2 people here, roughly maybe 4 people here, and roughly, I don't know, 5 or 6, maybe 5 people here. So I get 5 plus 4 plus 2 out of 77. I'm going to make this approximately. It's approximately at 11 out of 77. So numerically, when we're exploring one measurement variable, we look for the center, we look for the spread. Where's the middle? We calculate the mean, median, mode, which we did in Math 1112 by hand. We looked at that in Math 1112. We're going to get SPSS to do that for us this time. And this course. Spread. How far from the center are the individual data points? So any outliers, we look for standard deviation, variance, and range. And again, calculations. We did the calculations in Math 1112. And you can get SPSS or PSPP to produce those for you. Visually, we look at the shape. What does it look like? Bell curve, uniform, two-humped, skewed. We're going to look at a couple of different options in the next few slides. And the histogram helps us do that. Now, measures of center. Again, just a review for you. Range, standard deviations, measures of spread, and measure of shape. This is new. SPSS will calculate skewness and kurtosis. Skewness is symmetry. Is it leaning a little to the left or to the right, or is it pulled out? Is there a tail of some sort? So here are some different shapes. This is a left skew. This is, so I want you to think. This is pulled left. And that's why it's called a left skew. So that one, a lot of people have trouble memorizing. This is a right skew. So pulled to the right. So these two are the ones that you'll see most often. J-shaped or skewed, there could be kind of both of those. The normal distribution is kind of the nice bell curve that we always like to see. Rectangular is also called a uniform distribution. Because all values have an equal frequency. Bimodal means we'll see maybe an example of one example like that in this course. So in some shapes it's easy to see the center, and then in others, here, easy. So in the normal distribution, the center is right here. Here, it's harder to see. In the skewed distributions, it's hard to see. In J-shaped, it's very difficult. Bimodal, again, the center is pretty easy, but I don't know how meaningful it is. So there are a lot of issues once we get into the details. But for now, just get a sense of these different shapes and their names. Now, what happens when we have different standard deviations? So we're exploring one measurement variable visually, and we can see. So the pointier it is, so if you look at, here it is. A standard deviation of 1/2 means you have a very pointy and not a very, the spread is not very high. Once you get the standard deviation of 1, the spread is a little bit higher at similar points. And so that's where you have how the standard deviation makes a difference. The higher the standard deviation, the more spread out the points are. As you can see here, almost all the points are within 2 standard deviations with the first, with the blue graph, the dark blue graph. Whereas with the light blue graph, we have 4 sigma. Sigma equals 4. We have 4 sigma is huge spread, lots of spread. So I've gathered marks from the first test for 295 Math 11-12 students. So you're one of them last year. So I want to know, how well did the students do? That's my research question. How well do students do on the first test? And this is the data set here. It's just some of the individual points. And then this is SPS produces summary statistics. This is the numerical. And here's some visuals, right? This is the box plot. This is the histogram. And so here we have some individual scores, very low. And so we see the same ones here. So these, we would call these outliers. They also appear over here. So everything that you see in the box plot, you also see in this histogram. This is the one you've probably seen before. You'll easily get a sense of how the data is distributed. Will give you a good picture because you're more familiar with it. And the box plot is less. I'm sure most of you are not familiar with it, and you'll have to get used to it. And there'll be some exercises to give you a chance to do that. And you see the numbers here are also appear on the graph. So the median appears on the box plot. Exactly. And the mean doesn't appear on the histogram, but it's calculated by SPSS on the histogram. So these are all, they all work together. And you can get information from various. Now, just very quickly about the box plot. These are called whiskers. Bottom whisker, top whisker, center line, the median, 75th percentile, and 25th percentile. So these are marked here. And if you're not really sure what percentiles are, you should probably do a little bit of reading about them. I don't need you to know how to calculate them, but percentiles basically means, if you're the 25th percentile, means 25% of the people are below your mark. And remember I said, if you're in the 90th percentile, that means 90%, that means you're about here. This is 90th percentile. And so 90% of people's scores are below. Now, a little more. Okay, I've talked a little bit about the box plot. Preempted myself a little bit, and here you have a little bit more detail about the box plot. So make sure to spend a few minutes reading through, seeing how each of these 50th percentile, what does that actually mean? 75th percentile, what does that actually mean? And these are supposed to be pointing, sorry, they should be pointing up to the bars here. That one is. I guess we got a little bit off. So, what did we find out about marks? The research question was, how did students do? Well, we know that the average mark was 76.4, the mean. The median was 81.25, which is higher than the mean. We know that the standard deviation was 20.8. That doesn't really mean a lot to you right now. But we can see that it's a fairly high number in relation to the mean. If it was 5, then we know that there's not a lot of variability. But with 20, we know there's quite a bit of variability. And we could see that in the visuals here. We could see it here as well. We have a skewed distribution, so that's definitely a left skew here. And there's not much more to say about this. Students did fairly well. Some students did poorly, but most students did fairly well. So try to get SPSS or PSPP to reproduce these. Now, just a little word of warning to those of you using PSPP is that the version that I found for Windows didn't have the functions for plotting boxplot. You can get histogram through the numerical analysis. Now we'll look at a quick relating a boxplot to histogram. So exercise 5 will get you to practice with these. But what I've done is I've taken the test marks, so these are actual boxplots from the test 1 data. And what we can see is that when we superimpose the histogram over, the boxplot, this is the boxplot, over the histogram, remember this is the 100th percentile, remember this is the 50th, and this is the 75th, this is the 25th, and for SPSS they've chosen this to be the 0th percentile, below which all of these would be considered outliers. So you might ask, how do we know if these are outliers from the histogram? Well, you kind of know these are definitely outliers because they're all scoring 0. That's somebody who didn't even show up to the course, really, most likely. But for these numbers here, well, they may be outliers and may not be outliers. And so SPSS uses an algorithm to calculate which ones are outliers. And so if these are considered outliers by SPSS, that's good enough for me. So that kind of tidies up, or gets us going on exploring one measurement variable. Now quickly we'll look at exploring one categorical variable. So it's a very different process from exploring one measurement variable. Instead of summary statistics, we look at frequency of each category. So how many individuals said yes, how many individuals said no, how many individuals had red hair, blue hair, so on. Instead of the shape of distribution, we look at the relative sizes of the frequencies. That's what we're interested in looking at. So are there more red Smarties than other colors in a box of Smarties? So when we look at red ones, we can see there are 21 Smarties, which is the highest number of any of them. This is a total. So we have 21 Smarties. It looks like there are more red Smarties, definitely more than there are brown. And that represents a percentage of 24% compared to 6.9. Definitely more red than brown. Red and green pretty close. Red and blue pretty close. Alright, so this is our frequency table. Valid percent, this is so this accounts for missing data. and there's no missing data here, so we don't have that problem. And cumulative percentage just basically sums them up. If we add these two, we get 43.7, then we add that plus 6.9, we get 50.6, and so on and so forth until we get 100%. So it's a cumulative percentage. Take a minute, think about what the numbers mean for each of these. Visually, we'll see the same kind of thing. These bars, we have a few of them, blue, green, and red, have a lot more of them. Brown and orange, definitely a lot fewer of them. And this graph here, this is red. Blue is actually blue. Green is actually green. So when SPSS, I apologize for that, SPSS produces these colors, they won't necessarily give you the correct matching colors, but they might. And so you've got there's a function you can go in and change the colors for each of the slices. You'll learn how to do that. You'll learn how to do that eventually. So use SPSS to try to get this output, or PSPP. And I'll take a pause and make sure you try to do that now. Do most Canadians think they should do something to improve their health? This is from an actual data set and another categorical variable. So this is a simple yes or no. So in exploration, we try to suggest a possible conclusion, but really we're just exploring the data and trying to get a sense of frequencies, in this case, what the bars will look like, and we can see most people said yes. The problem here is out of 2,000 people, we have 1,300 who said, I don't care, I don't know, whatever, did not answer the question. So when we're comparing these yeses to nos, this information isn't there. So should there be a third bar? So when we're doing data analysis, sometimes this missing data becomes more important than the actual information that we want to study. And so that's something I just want to put in, make sure you're thinking about as you're working ahead. So this missing data is dealt with. Here we have 64%, and here, so it's these percent. So these are straight ahead percents, and then here the valid percents ignore. Which is the more correct percentage of people who think they should do something to improve their health? I'll let you. If we were in class, we'd have a little discussion about that, but I want you to think about that by yourself. Are you registered at PBWorks? Make sure you're at this site, not one of the other ones. This is the one that you need to be registered in.